this, we reject. Excellent. What if I get a number that is here somewhere? Anywhere here. What will I do?
Is it the alternative?
It's the fail. We never talk about the alternative at the beginning, right? We say fail to reject. H naught. So we either reject the null hypothesis or fail to reject the null hypothesis. So now one more time, what is the p-value? P-value here is this piece. We always reject when the p-value is less than alpha. But look, if the z statistic is here, look at the p-value. This is so much bigger than alpha. When the p-value is bigger than alpha, we fail to reject the null hypothesis. I want you to understand this, and I will repeat it till we get till we understand it, or as many times as you need it. So that's the claim. He believes that the percentage has decreased. Okay, so that's the alternative. Which of the following is the correct conclusion? Suppose the null hypothesis is not rejected.
Well, wouldn't there not be enough evidence to conclude that?
So if we do not reject, it means that it stayed the same. So that's why this is so important to present this on paper and look at it, right? So they are telling us that they fail to reject. Fail to reject. Which means there is sufficient evidence that this is still correct. I'm not rejecting it. So coming from this particular sample, I have enough evidence from the sample to conclude that this stayed the same, because I can't reject it. There is sufficient evidence to conclude that the percentage of teenage mothers has remained the same. Let's read the other three. There is not sufficient evidence to conclude that the percentage of teenage mothers has remained the same. No. There is sufficient evidence to conclude that I can't reject. It has stayed the same. There is sufficient evidence to conclude that the percentage of teenage mothers has decreased. Well, that has nothing to do with, right, because we fail to reject. That means nothing. I can't do this because we fail to reject. There is no support coming from the sample. There is no support that it has decreased. So there is sufficient evidence to conclude that the percentage of teenage mothers has remained the same. This is what the sample is telling us. Do not reject the null hypothesis. It remains the same. Now, if I collect the next sample next year or in 3 months, that may change. The result may not be the same. But coming from this particular sample, if I don't reject the null hypothesis, it means that the sample, there is sufficient evidence to conclude that the percentage of teenage mothers has remained the same. Otherwise, there is not sufficient evidence to conclude that they stayed the same, then I would have not rejected the null hypothesis. I would have rejected the null hypothesis. So there is not sufficient evidence to conclude that the percentage of teenage mothers has remained the same. Then it would have supported decrease, right? But it's not. Oh, I'm reading it something. I messed up something then. When the null hypothesis is rejected, we say that there is sufficient evidence to support the statement. But it's not rejected. But it's not rejected.
Well, what I was trying to say earlier is that I think they're trying to talk about the statement that the sociologist believes that the percent has decreased since then. In that point, there would be sufficient evidence to conclude that the percentage of teenage mothers has decreased.
But the null hypothesis is not rejected. But we're not rejecting that that the proportion is the same. Another way of saying it, it is true, there is not sufficient evidence to conclude that the percentage of teenage mothers has decreased. That's another way of saying it. There is not sufficient evidence to conclude that the percentage, so considering the claim. But even this one is correct. There is sufficient evidence if I can reject, but I would go with this, but it's the same. It's just there is sufficient evidence to conclude coming from this sample that the percentage of teenage mothers has remained the same. In other words, there is not sufficient evidence to conclude that the percentage of teenage mothers has decreased concerning his claim. That's fine. I agree. According to the Center for Disease Control and Prevention, okay, 9.5% of high school students currently use electronic cigarettes. So whenever you enter, remember percentages, it has to be in a decimal form. So it will ask us to enter the percentage 0.095. So do not enter it as 9.5%. So determine the null hypothesis, and we know that the null hypothesis has to be on proportions, right? We're not talking about the mean here. We're not talking about standard deviation. We're talking about proportion, right? It says 9.5%. This is an indication that we're talking about proportions. And the null hypothesis will always have which symbol? We know that.
Equals.
That's it. So now a high school counselor is concerned the use of e-cigarettes is higher. This is the key word. And of course, it has to be on proportions, same thing. But which symbol we use for higher?
Greater.
Good. So now, if the sample data indicated the null hypothesis should not be rejected, okay, we are not rejecting the null hypothesis, and let's focus on the claim. That's how they want the answer. That's fine. I agree with it. So that the proportion has increased. So let's look for that. So there is sufficient evidence to conclude that the proportion of high school stayed. No. There is sufficient evidence to conclude that the proportion of high school exceeds at this counselor's high school. So we are should not. Oh, the hypothesis should not be rejected. Oh, should not be rejected. Okay. Okay. Should not be rejected. There is not sufficient evidence to conclude that the proportion of high school students exceeds that, because it should not be rejected. Okay, let me read the other three just to make sure. There is sufficient evidence to conclude the proportion of high school students stayed. There is not sufficient evidence to conclude the proportion of high school exceeds. Okay, that is better. There is sufficient evidence to conclude the proportion of high school students exceeds. No, because we are not. Okay, there is not sufficient evidence to conclude the proportion of high school students stayed. Okay. Part B. Okay, suppose in fact, so we did not reject the null hypothesis. And it could be false. So that's a type 2 error, right? Was committed because suppose in fact that the proportion of students who use is this. Okay, so it's much higher. Okay, so we did not reject the null hypothesis and we made an error. The null hypothesis was false. What type? So it was false and we did not reject it. So that's a type 2 error. Type 2 error was committed because the sample led the counselor to conclude the proportion was this, when in fact is higher. Type 2 error was committed because the sample evidence led the counselor to conclude the proportion of e-cigarettes was this, when in fact the proportion is lower. Okay, So let me explain again. If we reject the null hypothesis when it's true, that's type 1. If we fail to reject, but it's false, it was higher, that's type 2. So the proportion of students was this, which is higher than the given proportion of 9.5%. This is 27.5, right? So it was higher, but we failed to reject the null hypothesis. So this is a type 2 error that was committed. Okay. Who would like to start this one? About the credit cards. Anyone I haven't heard from today?
I can read it.
Thank you.
Among all credit cards issued, the proportion of cards that result in default was 0.13 in 2010. A credit card analyst with a credit card company believes his proportion is different today. Complete parts A through E below.
Okay, so before we start, remember this is what we are given. So that's that P0. And here it says different. Those are the two key words. So I have the null hypothesis P equals that P0, which is, I'll copy it. And the alternative hypothesis is that P does not equal that P0. So P0 was 0.13. Because we're going to get to test these claims in the next section in a few minutes, right? So this is a two-tailed test where alpha will be split half and half here and here. If the z statistic falls here, fail to reject. If the z statistic falls anywhere in the tails, we will reject. If it falls here, then we determine the p-value, which will be definitely smaller than alpha, so that's why we reject. If it falls here, look at the p-value, much bigger. P-value greater than alpha, fail to reject. I'm preparing you for 10.2. Okay, so remember 0.13, 0.13. We have that. Of course, we're still talking about proportions because it says the proportion of cards. Okay, so of course you already told me, and this is different. The keyword is here. It says different, so I have to use different, and of course P. Explain what it would mean to make a type 1 error. So he believes that, okay, so what is a type 1 error? When we reject the null hypothesis when it is true. If the sample data leads to the analyst to reject the null hypothesis and the proportion of cards that result in default was not equal to, Okay, so let's analyze this one more time. So we fail to reject, we reject the null hypothesis when it is true. We reject the null hypothesis, but actually it is true. It has not changed. That's a type 1 error. Explain what it would mean to make a type 2 error. When we fail to reject the null hypothesis and it is false. Data is to not reject, fail to reject the null hypothesis, but actually it is false. It is different than 0.13. and the proportion of cars that result in default has changed. It's different. We cannot select any increased, decreased. No, we can't, because we're not talking about increasing or decreasing. We're talking about not changed. Okay, so let's analyze this one more time. So when we fail to reject a null hypothesis that is false, we fail to reject a null hypothesis, but actually the proportion has changed. This is false. It actually changed, and that's a type 2 error. Okay, 3 more oh no, sorry, we haven't finished. State a conclusion that would be reached if the null hypothesis was not rejected. There is not sufficient evidence at the alpha level to support the analyst's belief that the proportion of cars that result in default was different, not changed. Okay, so let's think one more time. So we do not reject the null hypothesis. There is not enough evidence to support from this sample and at this alpha level of support to support the analyst's belief that the proportion of cars that resulted in default has not changed. I'm thinking there's not sufficient evidence because we're not rejecting, so there is not sufficient evidence. No, hold on. There is sufficient evidence that alpha, the proportion of cars that result in default has changed. There is a particular wording they want, so just make sure. So the null hypothesis was not rejected. There is sufficient evidence coming from the sample that the proportion of cars that result in default has changed. Okay, we're not rejecting the null hypothesis. Okay, there is not sufficient evidence believe that the proportion of cars that result in default has changed. Okay, so the null hypothesis was not rejected. There is not sufficient evidence to show that it has changed. Okay. Okay, state the conclusion that would be reached if the null hypothesis was rejected. Okay, there is sufficient evidence to support such and such. The resultant default has changed. So be very careful, read this. I mean, I need to read them several times, as you see, because they're, it's just they can be very tricky. So we are rejecting the null hypothesis. There is sufficient evidence to support that such and such has changed. Tricky. Careful, read them more than once. Okay, so there are 2 more. I just want to move on to 10.2 because that's important. Okay, let me start a new video because I got to 18 minutes. Okay.